In Sydney, Australia, an industrial army is called into action.
No one has ever embarked on the scale of what we're doing here.
Deep out of sight, beneath the harbour city, a battle unfolds.
There's constant problem solving. Every day there's new problems, there's new issues.
Battalions of engineers pit giant machines against rock and mud to drive a new metro system through the beating heart of the city.
We have to get there, there's no other way.
The stakes are high and the clock is ticking.
You've got to take every bit of luck you can get, don't you, in this game?
This is by far and away the biggest public transport project in Australia's history. If I'm honest, I probably didn't quite know what I was getting myself into.
Got a problem?
Across Sydney, a small army of workers are reshaping an entire city, building a revolutionary metro system for the 21st century and beyond. When it's complete, this new driverless railway will have dozens of new stations, more than 150 kilometres of track, and create a giant loop around Sydney. But with mega ambitions come mega challenges. Major buildings to demolish in the CBD. Giant holes to carve deep underground. And more than 60 kilometres of tunnels to dig beneath the city. 8 monster tunnel boring machines are conscripted. North of the harbour, 4 TBMs dig eastwards and 2 dig southwards. And south of the harbour, 2 more tunnel their way northwards towards the CBD. Everything in their way is reduced to rubble. At the Barangaroo station site, design manager Ali Shard and the team are dealing with a startling discovery.
We found the oldest Australian-made boat.
See where that hole's been dug over there, next to the hull? That's where we got the keel.
Marine archaeologist Cosmos Coronius has uncovered where the boat was built.
Yeah. It's made out of Sydney blue gum, stringy bark and spotted gum, so local timbers. And that's what helped us conclusively say that it's an Australian-built vessel.
It's a wonderful find for archaeology, but the unearthing of this 180-year-old boat risks hindering progress. Every day the archaeologists' work is a day lost excavating the 25-metre deep station box. But after 3 long months, all the pieces have been tagged and removed and will now be scientifically examined and analysed.
So the archaeologists have finished taking the boat away, and we can now really get stuck into the excavation of the station.
Excavation was delayed in the area around the boat, and the race is on to make up lost time. The massive steel beams suspending the road are extended. Concrete is poured over one section. A roof is added so the team can work around the clock while keeping the dust and noise in. Beneath the roof, to make up for the lost time, excavation is back at full pace. With the harbour right next to the site, they don't want major water inflow, and so far, so good.
The material down there is quite dry. We're not getting major water inflows, which is something you'd expect next to the harbour.
Steve Kotovich is the construction manager at Barangaroo. Under pressure to get back on track, time is Steve's enemy. Time and water.
It would be tough going if we were to get a lot of water inflow. The truck's taking that material out of the hole. You know, a lot of material will be falling out of the back. All in all, it would just create a tougher environment.
Down here, necessity is the mother of invention. And building this massive ramp from excavated rock, or spoil as it's known, was a masterstroke.
We're utilising this ramp as long as we can. We're sort of on the absolute limit now as to how much more we can go. By having the ramp, it's helped us out a lot in that we can get the dirt out, you know, as quick as we can, which is really what we're here for, to get this excavation done as quick as possible.
The ramp raises their game and rights the schedule. But it's a temporary fix.
Over the next couple of weeks, the ramp will be phased out and we'll be lifting the dirt out using the clamshell excavator that you see over there.
No ramp means no direct access for trucks deep below, and the pace drops. Cranes are now called in to get dirt out to trucks on the surface. Still, 2,000 tons of dirt a day are moved out, threatening to add to congestion on Sydney's streets. The Barangaroo team must find another way to ship out its mountain of spoil.
So what's unique with the Barangaroo site is that the material that we're disposing from here is leaving our site via a barge.
At the other sites, we're taking the spoil away by truck. You know, it adds traffic to the city. Here, we've got a brilliant transport path using the harbour.
Behind me is the conveyor system. This conveyor is used to load the crushed material inside the spoil shed onto the barge that's parked on the waterfront.
One barge can carry about 60 truckloads of spoil. It's all stowed away to keep the neighbours happy.
We are in one of the prime vantage points of Sydney. There's a lot of high-rise around us. The minute we get a speckle of dust or a slight plume, the phone calls run hot. Doing everything we can to keep everybody happy.
And that includes recycling. This Barangaroo spoil is shipped up the harbour for use on other construction sites. As the station box gets deeper, walls of exposed rock tower over the underground site. Like a giant gemstone, the rock face is honed to reveal the natural beauty of the Sydney sandstone. It looks as solid as rock, but sandstone is porous, so water finds its way through. It begins to pool at the bottom of the box.
It's a challenging environment. It can get wet, it can get muddy. And until we've waterproofed the whole station and lined it so that the water can't get in, we've got to keep pumping it away. There's a lot of water coming in, so we just got to make sure that the pumps are working fine.
As pumps work full pace to keep the box dry, this operation could get stuck in the mud. And as more machines are drafted in, things get a bit too cozy for comfort.
The logistics is going to get really, really tricky, making sure that there's enough space for everybody to work in and everybody's not climbing over each other.
Just meters offshore from Barangaroo, right near the harbour bridge, the Geotechnical team are preparing for a risky mission to discover what lies beneath. Engineers need to know what type of rock they'll be tunnelling through deep below the harbour floor. Beneath the sand, silt and sludge. Ideally, there's only sandstone, like the surrounding city, perfect for tunnelling. Engineers will try to drill sample cores up to 80 metres below the water surface. They must know exactly what kind of material will be both above and below the tunnels. As the sun sets, 2 drilling rigs head out armed with the geologists' coordinates. This is a working harbour and busy transport hub. So in the interests of safety, the team must burn the midnight oil.
We're drilling on a waterway that is the most trafficked waterway in Australia.
World-renowned geologist Dr. David Ock is overseeing the drilling. It can only begin in the dead of night, well after the rush hour has passed.
This is probably the first time this sort of work's been undertaken on a harbour without interruption from major vessels, fuel tankers and cruise liners.
The platforms need to drill more than 50 boreholes and probes, all the way from the southern shore to the north. It's a 6-week job. As each core sample comes in, it is carefully analysed, and a map of the harbour floor takes shape.
Still quite. This is actually cohesive inside. The sand is just from it's just a kind of veneer.
There are some remarkable findings.
Becoming sandy here.
In one section, the harbour floor is 21 metres deeper than previously thought.
That's sand.
Far more concerning, towards the middle of the harbour, there's no rock.
Oh yeah, look at this. Wow.
There is instead soft, mushy sediment.
That's interesting. Look, it seems like it could be timber, actually. I agree. Look at this. That's pretty exciting.
Uncovering the harbour, right?
Amazingly, the core samples contain fragments of charcoal and timber.
Wow.
From 50 metres below the surface.
Yeah, so this material here is just charcoal timber, probably a bushfire material that's just floated down the ancient Sydney Harbour and deposited in the sand. Probably the first time these have been brought out in the open for nearly 20,000 years.
During the last ice age, the harbour was not a harbour. It was instead a valley, covered in forests, with a small river running down the middle of the valley towards the sea, which was then 25 kilometres further east. As sea levels rose, the ocean advanced west. The valley was flooded, and the forests drowned. The geotechnical results provide a wonderful insight into Sydney's remarkable past, but they make alarming reading for engineers. Instead of boring through stable, solid sandstone, tunnellers will face clay sediments, the remains of the ancient riverbed right in the middle of the harbour. It's a daunting prospect, especially with the massive weight of the harbour pressing down from above.
Most of Sydney is full of sandstone, a bit of a tunneller's dream. It's like carving out a bit of a hole in Swiss cheese. Really easy, really stable sort of material. But if you dive down under the water here, what you'll find is slush and sediment. And if I'm a tunneler, that's not my dream anymore. That's actually like trying to tunnel through yogurt. So imagine trying to cut a hole in yogurt and hope that that hole will stay there without doing anything. That's what our tunnellers have got to do when they try and get under this harbour. This little section from one foreshore to the other is an area that we're particularly concerned about getting right from an engineering point of view. First and foremost, we want to keep our construction workers safe while they're building it. And in the long run, we want to make sure that that tunnel is secure, not just for the next few years, but for the decades and centuries ahead.
In Guangzhou, China, the last TBM to roll off the production line is a very special rig. Called a slurry machine, its only job is to get through the soft ground beneath the harbour. Her name is Kathleen. Named after Kathleen Butler, the technical advisor to Sydney Harbour Bridge engineer John Bradfield. And while Kathleen Butler went over the harbour a century ago, her namesake is going deep under it. Her international crew has come to the factory, checking her systems.
The visual is open. Thank you.
There's Michele Petris from Italy.
The visual is closed, V14.
I feel very excited because I was waiting this moment since long time. It was a year of preparation, and now finally we have the machine ready to go, so I can really wait the moment to see the cutter head turning the first day.
Leading Kathleen's team will be Andreas Mint from Germany. He knows the conditions that await him beneath Sydney Harbour are perilous in the extreme.
You remember from your childhood days building a tunnel on a sand pit or out in the dirt. It's very soft material, so if you try to build a tunnel in this type of material, it just collapses naturally.
To stop the soft sediment or yogurt collapsing into the machine, the front of this TBM is highly pressurized, pumped full of liquid bentonite and high-pressure air to repel the pressure of the sediments and mud and stop it from flooding into the machine.
So we basically create an equilibrium between the existing pressure in the ground and the TBM, which is excavating the tunnel, making sure we don't get any collapse of the tunnel whilst we move forward.
Using high-pressure machinery underground is fraught with danger. So just behind the TBM's nose section are two hyperbaric chambers.
When we do work in the front, when we have to do maintenance on the cutter head, people need to go into this chamber.
These small, airtight rooms provide access to the nose section and also serve as compression and decompression chambers for the crew.
Working in compressed air is like diving. You might know when you go diving, when you come up, it takes some time to slowly come up. It's very much the same here when we do compressed air work.
Without the chambers, the crew would suffer the bends. Kathleen's crew must be able to handle working at the high-pressure business end of the machine.
We will train them on how to work in here, how to react if there is an emergency, and to ensure that they can work safely and carry out those works.
You'll always need to get in to check the cutter head. You have the scrapers here as well. You have a lot of wear parts on it, and you always need to go into the front to check. It's really important on any machine that's in the front line.
It's a potentially hazardous operation, far beneath the seabed, where nothing is more important than the safety of the crew.
The challenge of this job is, first of all, to keep a safe environment for everybody, because we are excavating under the harbour.
When we are tunneling under Sydney Harbour, there are no second chances.
Rod Staples, the city's transport chief and architect of the Sydney Metro project, is wary of the risks and dangers that lie ahead, tunnelling under the harbour. He heads to the UK to inspect a recent tunnelling project firsthand. In London, as in Sydney, these train tunnels had to be dug beneath a major waterway. In this case, the Thames. Simon Wright leads the British project.
It's a bit more like trying to cut through yogurt. The moment you dig it out, it all falls in on itself.
We have a lot of yogurt.
Yes.
But London clay is perhaps a bit more cheese-like. It's a kind of fairly solid yogurt. Pleased to say that the ground control, the settlement of the yogurt, collapsing in on itself was pretty good, thankfully.
How you doing with that?
Simon takes Rod on a tour of his Crossrail project.
It's 50 mil.
Where tunnelling sometimes came extraordinarily close to existing infrastructure.
We had to weave our way between the existing northern line and an escalator barrel. There's about 380 millimetres under the escalator barrel and about 500 millimetres above the northern line.
So the TBM was only that far away?
Literally that far away. And
in the highly specialised world of mega engineering projects, the best learn from the best.
If major programs can learn from each other globally and build upon this library of data and information and good practice, then we will all get a lot better, a lot faster at what we do.
But engineers are a competitive bunch, especially when the title of World's Best Metro is up for grabs.
For me, the battle will be won or lost on the systems and getting the testing commissioning right.
I'll back us to have the best customer outcome.
Oh, well, there you go. We'll see. We'll take a ride on each other's railway and we'll have a glass of wine on the outcome. How's that?
Look forward to it. Thank you.
Well done. Cheers.
Back in Sydney, it's a big day. The tunnelling team are taking delivery of Kathleen. After a long journey of more than 9,000 kilometres, she has to travel just 1 more kilometre to reach her launching site at Barangaroo. Unlike the other TBMs, however, she won't be making this trip by truck.
She gets transferred to a barge, which is going to end up here, and all the pieces we take off the barge and start putting all the pieces together. And there's a lot of pieces.
Kathleen's pieces are offloaded nearby at White Bay, a port also used for international cruise ships. The 3 largest components will be transported together, so they are being craned out of the ship's hold and lowered directly onto a barge. One by one, the huge sections of the slurry machine are gently loaded aboard. After some final checks of the all-important cutter head, the barge heads off across the harbour to her launching site. Since work is still underway in the station box, Kathleen will be assembled in her very own shaft.
So we're not just digging a hole here, we're also setting up to start our tunnelling works. We decided early on in the piece that we'd excavate what we call our northern shaft. And what that did, it decoupled the crossover cavern from the station box.
We could have started the tunnelling at the station here and going under the harbour, but it's a tight site. There's a lot going on, and it's just not the most efficient way of doing it. So it means that we can separate the 2 activities, and we can do the tunnelling at the same time as excavating the station box.
This has created more challenges. Kathleen's shaft had to be dug right under the Munn Street Bridge. The massive size of her largest components means it will be a tight squeeze.
Oh, it's pretty tight. The engineers at the start and our designers sort of left nothing to spare.
But that ordeal awaits. The more immediate challenge is getting Kathleen off the barge. At dusk, the largest pieces are floated in towards the shore. It's high tide, and it has to be. This mega machinery can't be craned off. It needs to be driven off safely as the barge floats next to the dock. To have the best chance of doing this, Andreas's team has brought in a special multi-wheeled machine called a self-propelled modular transporter, or SPMT. It's a scene straight out of NASA. Responsibility falls to Andreas to make sure nothing goes wrong.
A lot of preparation from the whole team. We now bring the machine from the barge onto the land and then at Barangaroo.
An SPMT is an extremely agile machine. Each axle can be moved independently and separately jacked up and down. Essential for transporting a massive load across uneven ground, which is exactly what it faces now, driving the huge TBM components off the barge.
So we drive the SPMT underneath the load, we jack the SPMT up, we pick up the load, and then we drive away with the load on the SPMT.
This is pushing the envelope. Even for a sophisticated and powerful machine like the SPMT, it must lift a 220-ton cylinder balanced on a barge, which is floating on water. If the SPMT doesn't lift the load perfectly level, the massive machinery and its precious cargo could tip over into the harbour. The team can't afford to put a foot wrong, but soon there's a problem. The tide starts to turn. And the lower the water gets, the steeper the climb to the dock. With every passing minute, the climb steepens, and the operation becomes more dangerous. The operator revs the massive engines, But it's still not enough. If they can't make it now, they'll have to wait for the next high tide. 12 costly hours away. One last push. And finally, solid ground. Andreas can breathe again.
Great to see the machine finally arriving here at Barangaroo.
Right in the heart of the city, another extraordinarily challenging station excavation is about to start. Martin Place, gateway to the heart of Sydney's global business and banking sectors. Like Central Station, Martin Place must stay open, while a whole new station is hollowed out below. Giant new metro caverns and tunnels will be carved out just a few meters away from the existing operating train lines. At the same time, enormous boxes will be excavated to support 2 new skyscrapers, as well as the station infrastructure like escalators, and the cafes and shops commuters will pass through as they descend to their trains. This new station is extraordinarily complicated and will eventually rival Central as one of Sydney's busiest. Above the station will rise 2 new landmarks, one 28 stories high, the other even higher at 39. Together, they will be a new workplace for thousands of people. But there's one major complication. This heritage building, 50 Martin Place, built in 1928, needs to stay exactly where it is. Once the city's tallest and most expensive building, its solid red granite base and ionic columns are a Sydney landmark. And it needs to stay that way, sitting above the massive new station that will be hollowed out below. Project manager Will Freelander is working with the buildings team to ensure it is protected.
Over 10 stories high, it's a full city block, and we're basically going to construct a railway station directly below it.
Working around and below 50 Martin Place without disturbing the historic structure is one of his more daunting tasks.
So we've got to do a whole bunch of geotechnical research, we've got to do investigation in the area to make sure that all those tunnels that we're going to put below are not going to cause the building to move in a way that would damage the supports or damage the facade.
Michael Silman is the project director for the station and the new skyscrapers. He also oversaw the complex restoration of 50 Martin Place. He is understandably cautious about all the caverns and tunnels to be dug beneath his back.
The National Trust has given it its highest category, essential to the heritage of Australia. So that's kind of a bar that not many other buildings in Australia have. We're not expecting any form of significant damage. There's a net over the stained glass window, and before the excavation works start, we'll be installing a net in the grand hall. So making sure we protect the heritage elements of the building is absolutely the top priority.
Will and Michael must take extreme care that the team's work around and below the bank does not undermine this grand old building.
It is grand. Probably not everyone's taste in their household, but certainly spectacular to visit, and I want to leave it that way.
Will has installed all manner of gadgets, the latest technology, to detect any unexpected and unwanted movement.
We have noise and vibration monitors on multiple levels in the building and in multiple areas. We've got noise meters measuring the ground-borne noise that's travelling through and also the airborne noise that's coming through the windows. And we've also got vibration meters down here picking up the ground-borne vibration. You come in here and you see the marble features and the columns, you really understand that any changes below could affect, the 12 or 13 stories above.
And we have a process where we get together and analyse the data, so that gives us a lot of comfort that things are being well monitored.
50 Martin Place is in safe hands, but the buildings next door are destined for demolition. and reducing them to rubble falls on the shoulders of Brian Marshall.
Mid-city demolition is quite high risk. We're taking down a building, one of them's it's at 28 stories high. We've got to put the machines on top of the building in the first place.
As night falls and city blocks are shut down, the team prepares to lift excavators onto the tops of the buildings they need to demolish. Great care is taken attaching the chains. No one wants to see a 3-ton machine plummet back to street level.
We need to work out what pressures those cranes are going to put on the pavement, because there are services, there are access tunnels and different structures that are directly below the pavement. We need to make sure that we're not going to cause damage to those or cause the pavement to fail and have an issue with the lift itself.
The first of 3 excavators makes it onto the roof, 80 metres above the streets below. In the coming days, the wrecking crew gets to work, turning concrete to rubble and dumping it all down the centre of the building, where the lifts used to be. This is the fastest and most efficient way to get rid of a high-rise building in the middle of a busy city. Adding to their challenges, Will and Brian have to keep the decibels down, within strict limits.
We fully acknowledge that we are in the middle of the central business district, and so one of the methods we use is, wherever possible, we employ munchers rather than rock hammers, which use hydraulic power to crush the concrete rather than using the hammers which belt the concrete and create a large amount of noise.
We have noise limitations for what we can do and for how many hours. We need to give respite times. So we normally only hammer for 2 hours, then respite for an hour.
The quicker they can make these buildings disappear, the better. And the demolition soon hits full pace. It takes just 6 days to demolish each floor. Soon, the 2 buildings to the north of 50 Martin Place disappear, followed by the 28-storey building to the south. Once they're gone, digging the southern shaft can begin. Responsible for designing Sydney's new metro trains is Frenchman Xavier Allard. He wants to give the trains a unique Sydney touch and has found his inspiration at the Royal Botanic Garden.
I think it could be really interesting to use the idea of roots coming from the ground for the front end of the train. So it could be interesting to express stability, to express something capable to give confidence to the passenger. I think it could be good and could be unique also for Sydney.
Back in Paris, Xavier and his team try to bring this vision to life.
Sometimes it suits, sometimes it doesn't suit. As the tree coming from the ground. And sometimes it's really, really, really important to change our position, to change our inspiration in order to fulfill with the customer expectation. And you know that the design theme of your train is based on the tree. Yes. So if you look at, for example...
Rod Staples likes Xavier's design for the front of the train, but he's more concerned with the train interiors. And the pair use the latest 3D technology to walk through the concept train.
So the handholds, most people will be able to reach those, or will only be for tall people like me?
We have tested.
The talk with Xavier was you wanted a real sort of modern feel, but a spacious feel.
Yes, so the old metros didn't have that because they were all closed off, but the newer metros have opened that up, and you can watch the train meandering through the tunnel, and it gives you a real
colour schemes and so forth were a big topic, and wanting to make it light and vibrant.
Yeah, it's something we are in progress.
By chance, the architect in Sydney designing the stations on the Northwest Line has also been inspired by nature. For Ross Delamotte, the leaves of the local blue gum tree are the key.
So what we have here is the arching form of the roof, landing on either sides.
Yep. Call it coincidence, call it divine intervention. 2 designers working independent of each other have come up with a great idea, and sometimes people think you do things deliberately, sometimes you just have a bit of luck.
So can you do a rotate?
The canopy forms of the stations, they're not purely a leaf form, but you can see the organic nature of that beautiful form draping over the concourse. I'm a very strong believer in the importance of getting the engineering right. These jobs are so big and so complex that you have to solve the engineering problem, but you can actually use the engineering design criteria to make beautiful structures.
No doubt I had high expectations from the very beginning about what we'd create here, and there was two very strong messages. Think outside the box and really push yourself to come up with a great design.
Transport's brief to us was to really create the next generation of transport excellence.
That's it. That's it. Yeah, we're cooking.
I gave them the space to go and do something extraordinary, and I think they did more than that. I think he absolutely nailed it.
Tunnel boring machines are remarkable, efficient, mobile tunnel-making factories designed to keep workers safe, deep underground. Refined over many decades, the TBM design means the crew is never exposed to unsupported rock. Simply, the concrete tunnel is built inside the machine. As it moves forward, like a giant mechanical worm, it leaves a finished tunnel behind it. The concrete segments are brought up into the machine, and a robotic arm lifts each one. The segments are secured to the others and bolted into place. 6 concrete segments make up one ring. Then powerful hydraulic arms push off the latest ring created, providing the force to move the TBM along the tunnel. All the while, spoil is constantly being conveyed out the back of the TBM and down the tunnel on giant extendable belts. TBM Nancy started tunnelling from Marrickville 4 weeks before her sister, Mum Shirl. But the difference is now down to less than 2 weeks. Mum Shirl is catching up. It seems rivalry is alive and well between competing TBM crews. Brendan Timmins is the TBM operator on the Nancy crew.
We did have a good lead on them before, but they're probably a bit closer than what they were. But yeah, it's all good. Just a bit of friendly banter with the boys.
Just friendly banter? Sure. So who will be the first to the finishing line at Barangaroo?
We're TBM 1, so I'm hoping TBM 1 does. There'll be some bragging rights there, I dare say, yeah. We started before them, so I sure do hope we finish before them anyway.
Timo fears that going first, being the pathfinders, could be a disadvantage.
I suppose any little dramas that you do have, like, they get a little heads up. We're the guinea pigs, really, so...
Timo and the other crews keep track of whether they're getting ahead or lagging behind by keeping a tab on the number of rings they've made compared to the other crew.
I checked on the conveyor screen, we were 377 rings in front. I think we're back down to only 100 or so. So, boys, ring up, how many did you get today? And it's the same as anything. Hopefully we break through first, but whatever it is, it is.
Breakthroughs are grandstand events. On the Northwest Line at Hill Showground, a large crowd gathers for the big moment. It's not long before TBM Elizabeth makes her presence felt. After devouring almost 430,000 tonnes of rock over just 4.2 kilometres, TBM Elizabeth gently noses out a small slab of rock. Almost there, she makes one last push. But suddenly, a huge piece begins to fall further to the right. For an alarming moment, the entire wall shudders and huge rock slabs begin to fall. Then Elizabeth smashes through into the light. It's been a long, hard journey, and her battle scars are clearly visible. Over the coming days, she traverses the station box towards the city end and plunges back into the darkness once again. back at Barangaroo, it's time to put the specialist slurry machine, TBM Kathleen, to work.
Front sheet.
Yeah.
And you've got the one for front sheet and rear
If the
sheet.
angle is not straight, we can crush with the top side. We're crushing this hill and we damage this hill.
The team finalizes the plan, get the components underground, then assemble.
So when I bring it in, I will make sure the trailer's 100% level, and then from there you just give us the instructions.
We're working together and we see which position is better.
And the only thing I want to tell you is that when we are on the final lift, the clearance that we've got is very tight.
Okay.
Very, very tight.
The shaft that Kathleen's components will be lowered down is 340 meters away across the road, above the station box. The road authority has agreed for traffic to be stopped only between the hours of midnight and 5 a.m. One of Sydney's most popular celebrations, the Vivid Festival, is currently in full swing. With only 5 hours to get Kathleen to the shaft, Andreas is up against it.
Tonight we will bring the front shield first and then the middle shield from here out to the side, across the road into the shed, and then down into the shaft and into the large cabin later. Sounds easy, a little bit more tricky than what it sounds. First of all, we have to cross the road, which we can only do with the road closure.
Andreas's right-hand man, Vincent Ganay, gets ready for the green light.
At 12, we've got the road closure. So we are gonna get first front shield and then the rear shield across Ixon Road. We're gonna get to the shed and lift everything down.
Tonight, it's critical that we get those two pieces across the road. Otherwise, we'll be in big trouble. There will be challenges, that's for sure, but we have the right people here to tackle them and to sort them out as we approach them.
It's going to be very tight, both in terms of time and the space available beneath the Munn Street Bridge.
There wasn't enough space because they came up with 13 meters, but when they measured it, it was only 12.5. So
Andreas confers with Jamie Chirk, one of the site engineers. There's been some confusion about the amount of clearance beneath the bridge.
So and if he puts this 12.5 in, it's almost exactly 13 meters at the top, so there shouldn't be a problem.
By Andreas's calculations, there's less than half a meter to spare.
At 400 mil, there should be enough space, and also the angle, it should be okay.
And as far as Andreas is concerned, that's enough. It's go time. At 11 o'clock, the SPMT gets the first giant piece of Kathleen on the move.
Yeah, it's just you can't see because the light is in the way.
It crawls towards the road. When the road closes at midnight, the team want to be ready.
Make straight and keep that line. Make straight and keep that line.
Okay, we have 5 hours now. The road is closed. We need to get the TBM across the road. Let's go.
The countdown is on. With 190 tons of machinery on board, every move must be inch perfect. There's already over an hour on the clock, and the next obstacle, Munn Street Bridge, is yet to come. The top of the cylinder stands over 12 meters above the road, but mere centimeters below the bridge's concrete slabs. Andreas hopes that his calculations are correct. It's all way too close for comfort. Then, it's through. But the tightest squeeze is still to come. The massive load maneuvers towards the shaft.
And now they'll be rigging it up with the gantry crane, the overhead gantry crane, the yellow one there, and then lowering it down the shaft into the tunnel.
So we are going to lower the TBM shield down into this hole. It's an extremely tight spot. The machine just fits into this hole. It will become clear how small that shaft is, just millimeters on either side, so a very delicate operation.
With millimeters to spare in some places, Andreas is understandably anxious.
Once you start lifting, there's no going back, so...
It's do or die time. A gantry crane brings the massive load out over the shaft and begins to lower it towards the bottom, 30 meters below. In places, the giant cylinder comes within a whisker of the sheer rock walls. But the team hold their nerve. And she's through without a scratch.
That's one down and 2 to go.
The SPMT heads back for the next piece, taking time out for a quick pit stop.
We're just stopping for a bit of fuel, and as soon as we finish filling up, we'll get back into moving the shield. 2 hours and 15 minutes. We should be able to make that easy. I have no problems at all.
I think we're good for time. We'll load up the second shield and then take it across the road.
The second shield is bigger than the first.
This is the biggest piece of the TBM, so it's critical that the guys get it lined up properly for when we're crossing the road. We've got about 2 hours to go at the moment. I reckon we're making plenty of time. Bigger than our last section, so it's going to be a bit tighter. This one is the most challenging.
The SPMT strains against the enormous weight and gets on the move. The real test will come when it reaches the shaft and crane.
This piece is 220 ton. The crane capacity is 220 ton. So this one will go on full capacity on the crane there.
The shield makes it across the road and glides under the bridge. The team just make it before the road reopens.
The road is open now, yeah. Thank you.
Now it's test time for the gantry crane. Right on the limit of its lifting capacity. There is zero room for error. In a night of tight squeezes, this is the tightest. With anxious eyes watching, it finally arrives. At the bottom, the team inches the 220-ton monster into position and joins it to the first shield. The next piece to descend is the cutter head. The gantry crane over the shaft is the only crane that can lift any of the 3 mammoth components. The last piece of this giant jigsaw is finally ready to heave into place.
It's a big puzzle and very challenging. Bring the cutter head down, have to come back in again.
The crane lifting point is moved from the center to the side of the cutter head. It's now suspended in mid-air, like a giant target. Take aim, bullseye. While Kathleen is being assembled, so too is the crew that will carefully guide her voyage beneath the harbour. The internationals, Vincent, Michele, and Andreas, are joined by Aussies, Red Dog and Griffo.
My name's Daniel, known as Red Dog. Red Dog. Well, yeah, I don't know where the red come from, but...
Engineer Jamie Chirk has also joined the team. She has never worked on a TBM before.
This is my first TBM, so I'm very excited actually, because I'll be learning so much new things every day. It's probably around 80. I'm also very nervous, anxious, for the same reason that it is all new. I guess when something does go wrong, it's just good to know like what sort of decision we need to make at the time.
Next time, TBM Kathleen faces her biggest challenge in the mud under Sydney Harbour.
If you drop the pressure, the water would just race in at this moment, absolutely race in. It's a bit of a critical time, it really is.
Mass graves are discovered in the middle of Central Station.
Unfortunately, we've got to quarantine the area, hand it over to the archaeologists, and they'll do their work on it, and hopefully hand it back to us pretty soon. Fingers crossed.
And at Martin Place, deep underground obstacles present a major challenge.
So we come within 2 metres of the existing eastern suburbs rail lines, and we actually come within 500 mil of the tunnels that we're constructing at the moment.